Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So finally, we are on this particular paper that is of November 2024, variant 1.3. It's a walkthrough solution. That means almost the whole paper is solved and we will go over the solution. So we are starting at 7:42 p.m. and I think it should take around like 45 or 50 minutes. So let's start with the first thing. Let me grab my highlighter so I can underline the things and you can have a good look. Question number 1, it says an arithmetic progression has a fourth term 15, eighth term 25, 3 marks. Find the 30th term of the progression. A very basic question. You have the fourth, you have the eighth term. Fourth is a plus 3d. Eighth is a plus 7d, simultaneous equation. So you can change sign of this thing. So let me write a negative over here, a negative over here, a negative over here. Therefore, the first equation is negative 4d is negative 10, negative, negative cancel. We find the value of d, which is 2.5. Now plug this value of d in any one equation. Let me plug in equation number 1. So that's the value of d. That is 3, that is a, that is 15. A comes out to be 7.5. So now we have a, now we have d. Find the 30th term, that is a plus 29d. Use a calculator and then you get this exact answer. There is no rounding off. Let's move ahead. Question number 2. Let me start the highlighting. Question number 2, find the exact solution of the equation, this thing. So now it's a good question. There are several things to take care of. The first thing is the value of x lies between negative pi by 4 and pi by 4, and the equation has a 2x in it. So I have done it later, but there is no harm in telling you from before. So therefore, 2x, it lies between negative pi by 2 and positive pi by 2. That means you are going in this quadrant, that is 0 till positive pi by 2, that's the first quadrant, and 0 till negative pi by 2, that is the fourth quadrant. So you're dealing with two things. Now let's work it out. Cosine of pi by 6, the exact value. So cosine of pi by 6, that's root 3 over 2. And when you transfer it to the other side, that's already a 3 over root 3 over 2 over here. It's on the same side. So that's one term, that's the other term. So basically, this becomes tangent of 2x plus 2 root 3 over 2 equals to 0. And then you have this particular equation. Now, always remember, it's a 4-step solution. The first step, it's about quadrants. The second step, it's about modification of range. The third step, make a habit of writing it. That is, let alpha be the basic angle, the acute angle with x-axis. We always calculate it with a positive ratio. Please take care of it. Alpha comes out to be pi by 3. We are working in the exact form. We are working in terms of pi. And then the final solution. So the final step is to solve for the variable x. Now, since we are dealing with second and fourth quadrant. Second quadrant is not part of the domain. So therefore, this is out, this is in. So we are only dealing with the fourth quadrant. That means we are going clockwise. And over here, theta is equals to negative of the basic angle. Theta is negative pi by 3. Make x the subject. X is negative pi by 6. So this was slightly more difficult, but just look at the marks. It's only 2 marks. I think it's worth much more than that. But sometimes difficult questions carry low mark. Very few of them. Now, the third one. Now over here, let's focus on this. That is find part A. There should be a part B also. They are on the same page. Let me read the whole thing first. Find the coefficients of x cube and x4 in the expansion of this bracket where A is a constant. Give your answer in terms of A. That's for 3 marks. And then it says, given that the coefficient of x4 in the expansion of these two brackets multiplying together, it's 240. Find the positive value of A. Now, first of all, this is the simple expansion. That is this one that is already highlighted over here. That is NCR. And A raised to power of n minus r. And then it's b to the power of r. So over here, this thing is B along with the negative sign, and this thing is A. Now let's look at the working. 5C3, because we want a power of 3 over here. B raised to power of 3, negative raised to an odd power remains negative. And then this is A raised to power of the difference between 5 and 3, which is 2. Simplify, isolate the coefficient. So over here, this is what you are getting. So you are getting this thing. This is minus 90. That's the coefficient of A cube. Similarly, we want coefficient of A power 4. Again, we do the same thing and we are getting 15 and A power 4. This is the coefficient of X4. So this is X4, this is X cube, this is coefficient, this is coefficient. Write it out separately if you want. Now, overall, we need the coefficient of X4. That means which terms are we looking for? We are looking for the X term. It should multiply with X cube term. That will give me an X4. We are looking for a constant. It should multiply with X power 4 and so on. So take the coefficient, multiply with this coefficient, take this coefficient, which is A, multiply with this thing. And then it's all A power 4. So therefore, A power 4 is 16. Whenever, remember this thing, whenever we talk about even root, whether it's square root, whether it's fourth root, whether it's sixth root, and so on, we can only take even root of a positive number, and it comes out to be positive, it comes out to be negative. So therefore, A power 4 is 16. A is basically plus 2. A is negative 2. This is accepted. This is rejected. Keep that in mind. So now this thing is done. Question number 4. Question number 4 says, solve the equation. It's one single equation. Now, we already solved a trig equation now. So what's the difference? It's the same kind of thing, except that some exact values were used. And this one, it's like a disguised quadratic equation. So what do we have over here? We have sine power 4 theta. This is sine square theta. This is in degrees between 0 and 360. So now that one was in radians. This one is in degrees. So this is disguised quadratic equation DQE related with trigonometry. Let m is equals to sine squared theta. M square is sine power 4 theta. 4m square plus 12m minus 7 equals to 0. Then its middle term factorization. Have a good look. We are getting two values of m. M is positive half. M is negative 7 over 2. But what is m? M is sine squared theta. Cannot take square root or an even root of a negative number. So that is why there is no solution from this one. From here, sine squared theta is half, sine theta is plus minus 1 over root 2. Again, let me do the rest of the steps, all 4 quadrants. 2 for positive, 2 for negative. Is there any modification of range? Nothing as such. So therefore, theta lies between 0 and 360 degrees. And then let alpha be the basic angle. Sine alpha is 1 over root 2. Therefore, alpha comes out to be 45 degrees. Very basic working. And then we have the final answer. Theta is 45 in the first quadrant, 180 minus 45 in the second, 180 plus 45 in the third quadrant, 360 minus 45 in the fourth quadrant. So that is 45, that's 135, that is 225, and the last one is 315. All answers are exact. There is no rounding off. They are already in integers. So that's how this particular question, that is, we get this thing. Now, question number 5. Now, question number 5 was slightly tricky. So are most of the transformation questions. So don't let it get to your nerves or to your head. Skip it, come back to it later. If you can manage it, well and good. If you can't manage it, still you'll be able to do something with a cool mind. Now it says over here in the diagram, the graph with equation y is equals to fx is shown with solid lines. And the graph with equation gx is shown with broken lines. So this is fx, it's written. This is gx, it's written. Describe fully a sequence of 3 transformations which transform the graph of fx to the graph of gx. Now, it seems like there is some kind of reflection. So this is like this is like this, and this is like this, and then it's kind of a stretch. Or First, you can do translation in this direction like this, and like this. And then we can do the reflection and then the stretch. So let me go it in this direction. So first of all, that's a red color. And let me, no, this thing I bought. So now over here, where is the eraser? There it is. That is one part. And let me draw parallel to this like this. And then there is this part. Let me shift it 1 unit this way. And then there is the green part like this. So let me shift it like this. So that is the first thing that I've done. So reflection, and then there is a translation. So I'm doing translation first. This is a horizontal translation. It's of 1 unit. Translation vector is 1, 0. So this is my step 1, the first transformation. Now I'm reflecting it in the y-axis. So have a good look at it. So now this thing is going like this. And then this blue line, let me remove the original thing. This is gone, this is gone, this is gone. That is gone. So now focus on this one. That is this thing. And then the blue line is this thing like this. And then the green line, that is something like this. Okay, so that is after stage 1, and stage 2, that is reflection. So over here, let me write step 2. That is a reflection in y-axis. And now look for the third part. Look at the base. The base is not changing. That means there is no stretching along x-axis. What about the height? This is like 2 units. Now this height between the two corresponding points, that is over here. Let me just remove this thing. So now this, between this point and this point, it is like 2 units. And between this point and this point, it's like 4 units. So yes, there is stretch along y-axis with a scale factor 2. So that is the third step. That is step number 3, stretch along y-axis with a scale factor 2. Now, some people, they can also do it this way. They can first reflect. They can then translate 1 unit to the left and then do the stretching. So that is perfectly fine. That's written in the mark scheme. Find an expression for gx in the form a, f, b, x plus c, where a, b, c are integers. This -1 is there for the reflection in y-axis. This -1 is for the movement to the right. This 2 is for the stretch. That is how this thing is written for 2 marks. Let's move on. Question number 6. Now, question number 6, it says the first term of a convergent geometric progression. What do we mean by convergent? Sum to infinity exists. That is one thing. And common ratio lies between +1 and -1. And sum to infinity exists. That's the first thing. The sum of this convergent thing is 10. The sum of the first 4 terms of the progression is P. The sum of the first 8 terms of the progression is Q. This is the ratio that's given between the two. I have cross multiplied and written it like this. Find the 2 possible values of the sum to infinity. That means there are 2 possible values of common ratio. That is one value, that is the other value, and then you will find the sum to infinity. Now I have written the information. Let me write it. A is 10. Sum of 4 terms is P. Sum of 8 terms is Q. Sum of 4 terms, that is A, 1 minus R power 4 over 1 minus R. That is written as this. And then the next thing, Q, that is S8. That is the same thing. Now over here, 16Q, I have cross multiplied. 16Q is 17P. 16 times this, 16 times this is 17 times this. What cancels out? 1 minus R cancels out. A cancels out. We are left with 1 minus R power 8, 1 minus R power 4. Cross multiply, we again have this guy's quadratic equation. Now people try to understand this thing, that it's a very heavy duty emphasis on algebra, whether it's about indices, whether it's about algebraic manipulation, whether it's about expansion, whether it's about factorization, whether it's about simultaneous equation of any type. whether it's about disguised quadratic equation, whether it's about quadratic. So its algebra is in the air. So don't be afraid of algebra because that's part of life. That is part of your P1 paper. So you have to work through it. Now let m is equals to r power 4. So therefore, this is 16m square. M is r power 4. Therefore, m square is r power 8. 16m square minus 17m plus 1 equals to 0. Therefore, 16m square minus 16m minus m plus 1 equals to 0. 16m m minus 1 minus 1 m minus 1 equals to 0. Therefore, let me write a step over here because I have just worked it out like this. Okay. So therefore, what do we have? We have m is equals to 1. We have m equals to 1 over 16. But what is m? M is r power 4. M is r power 4. R power 4 is 1. R power 4 is 1 over 16. And that is the working that we have done so far. So now, when these are the values that we have, why are we rejecting this thing? What's wrong with this? Because the common ratio should lie between -1 and 1 non-inclusive. When r is equals to 1, it does not form a convergent geometric series. All the terms would be exactly alike. So r is plus minus half. When r is positive half, sum to infinity is a over 1 minus r. A is 10. So this is 10 over 1 minus half. And this sum to infinity is 10 over 1 minus minus half. So this is one answer. This is the other answer. So now question number 7, circular measure. Have a good look at it. First, look at the diagram. What I see is a major sector over here. And this angle will be 2 pi minus 2 theta. So let me draw a few lines. So that would be helpful for me before reading the question. This one, that is like this. And if I can get hold of this red thing and this arc kind of thing, I hope it can do the job like this. No, it won't. So now it's like this. I'm just marking it. So this is the major sector like this. And this angle over here, that is 2 pi minus 2 theta. And the radius is 20. The radius is 20. What else do you see? You see some triangles. So there is 2 congruent triangles. This one is one triangle. And this one is the other triangle. The angles are this thing. And the length are 20 and 20. The same thing, 20 and 20. The angles are theta and theta. Now, these are not sectors. I haven't read it as yet, but definitely these are not sectors. These are semicircles. I mean, that I read later on. So now over here, look at it. The diagram shows the metal plate consisting of 5 parts. The parts BCD and DEF are semicircle. So these two are semicircle. So let me highlight this. This is a semicircle. This is a semicircle. So now it's all clear. Semi, semi. They would add up to become a circle. This is the major sector. And then there are 2 triangles. There are no segments in this question. And all the lengths are given and angles are given. First part, given the theta is 1.2, find the area of the metal plate. Give your answer correct to 3 significant figures. Now they are making us work in significant figures. I'm just looking at one thing. That is the recording and everything. That's all good, all clear. Now it says area of sector BOF. Area of sector BOF, that is half r square theta. That's 2 pi minus theta. Minus theta, that comes out to be this thing. This is in centimeter square. Work in 5 significant figures. BD. Now, how do we find BD? If I have this side, and this angle 1.2, I can use cosine rule. So let me just write the step over here. Therefore, BD square is equals to 20 square minus 2 into 20 into 20 into cosine of this angle, which is 1.2. And make sure your calculator is in the radian mode. And you find BD, which is the same thing as DF, that is 22.58. All good, all clear. Let me just copy this cosine rule. That's right over here. So this is centimeters and this is for significant figure. Area of semicircle, that's half that of a circle. And there are two semicircles. So this is two semicircles. Total means semicircle area of two semicircles. That is coming out to be this thing, centimeter square. Area of triangle, there is two of them, half AB sine of this thing, that comes out to be this thing, centimeter square. So now let's highlight everything because this is what you're going to do in the exam. You have to highlight. So that is the area of the sector. That is the area of two semicircle. That's the area of two triangles. The total is this thing, correct to three significant figures. All good. Now, next part, given instead, that means theta is no longer 1.2 radians. And now you might have to first find theta, which you will. The area of each semicircle is 50 pi. Find the exact perimeter of the metal plate. Now, what is the exact perimeter of the metal plate? That is this circumference plus this circumference plus this thing over here. And let me remove all the colored thing so that we can exactly see what are the solid lines. So all you have to do is find this, find the major arc length. Now we have this thing, the area of the semicircle is there. That means based upon that, I can find the radius. Based upon the radius, I can find theta. Once I find theta, I'll be able to find this arc length and this arc length also. So now what's the strategy? Area of semicircle is 50 pi. Area of semicircle is half into pi into r square. Pi cancel. R square is 100. R comes out to be 10. So that is the first thing. Centimeters, exact value. Diameter is 20. Now when we have the diameter is 20, what new thing is unlocked? That is, this is 20. This is 20. This third one is also 20. That means it's an equilateral triangle. So therefore, this angle is theta, this angle is theta, this angle is theta. All these three are theta. So therefore, 3 theta equals to pi. Therefore, theta is pi by 3. That is unlocked. So now over here, theta is pi by 3. That's also done. Arc length major, that is r and theta, a big theta, or let me call it phi. What is phi? 2 pi minus pi by 3 minus pi by 3. So 2 minus 2 over 3. 3 2s are 6 over 3 minus 2 over 3, which is 4 over 3 pi. So this comes out to be 4 into 20. That is 80 over 3 pi centimeters. That is the major thing. Arc length of each semicircle. That is circumference of a circle. That is 2 pi into r. R is 10. Make sure you don't confuse the radius and the diameter. That is 20 pi. So therefore, the total perimeter, that is 80 over 3 plus 20, take pi common. 3 into 20 is 60. 60 plus 80 is 140. That is 140 over 3 pi centimeters. And this answer is in the exact form. That is the fraction or pi or surds. Now this thing is also done. Question number 8. Now, what is question number 8 all about? Question number 8, the first part expressed in the completed square form. Second part, the function fx is defined for x is greater than or equal to k, where k is a constant. Find the least value for which the function exists, or it can also say the function is 1 to 1. Now, we know that 1 to 1 function exists. Only 1 to 1 function has an inverse and vice versa. Now, first thing, completed square form, no rocket science in it. Make sure the coefficient of x square is 1. Take 3 common throughout. That is the way I do it. And then first two terms as it is, constant push on the sidelines. First add, then subtract. So let me highlight this thing. First add, then subtract square of half the coefficient of x, square of half the coefficient of x. Rewrite the first 3 terms as a perfect square. So this is what you get. And then simplify the rest. Open up the bracket with the 3. So 3 multiplies with this, 3 multiplies with this, 3 multiplies with this, and then you get this thing. And right away, write this thing, the gold standard form, that is the completed square form. H is 2, K is 2, that's the turning point. And we know that A is positive, so it's a minimum point. Now, the least value for which function is 1 to 1. That's right of turning point or left of turning point. Whether they ask for the least, whether they ask for the greatest, it's always x coordinate of turning point, which is 2. For the rest of the question, what are they asking? They are asking us to stick with the value of k that we found in part B. So basically, for fx, the domain is whatever fx is, that is what? 3x minus 2 whole square plus 2. 3x minus 2 whole square plus 2, and the domain is x is lesser than or greater. It's greater, my bad. So that is greater than or equal to 2. That's the domain. Find an expression for f inverse. Very simple. Let y is equals to fx. Therefore, f inverse y equals to x. 3 bracket x minus 2 whole square plus 2 equals to y. And y minus 2 divided by 3 is x minus 2 whole square. Y minus 2 over 3 square root with a plus sign is x minus 2. Why is it a positive sign? Because we are going to write off turning point. So therefore make x the subject. Therefore x is 2 plus square root y minus 2 over 3, but x is f inverse y. We have a habit of writing everything in terms of x. That is 2 plus square root x minus 2 divided by 3. So that is pretty basic stuff. Hence or otherwise, solve this equation. F of x is equals to 29. First thing, fx is this thing. F of x, that means whenever there is this thing x, what am I substituting? So in place of x, I am substituting fx. And the next step, I have actually substituted it. For first of all, instead of x, I'm substituting fx, f of fx. And then fx is this thing, 3x minus 2 whole square plus 2 minus 2, this whole square plus 2. I mean, there is so many repetitions. So there is a very high chance of making a mistake. So now this is 3 bracket square. Let me keep it secret. Plus 2 equals to 29. 3 bracket square is equals to 27. Bracket square is equals to 27 over 3, which is 9. Therefore, bracket equals to plus minus a 3. It's not over yet. So that's a plus and a minus 3. And now what's inside the bracket? 3x minus 2 whole square plus 2. 3x minus 2 whole square plus 2 equals to 3. 3x minus 2 whole square plus 2 equals to negative 3. So now 3 bracket square x minus 2 whole square, 3 minus 2 is 1. X minus 2 whole square is 1/3. X minus 2 is equals to plus minus 1 over root 3. And then we find the value of x, which is 2 plus minus 1 over root 3. And over here, this is 3x minus 2 whole square is negative 5. X minus 2 whole square is negative 5 over 3. Stop, because we cannot take square root of a negative number. Not applicable, not possible. So now what are they asking? Solve the equation. Now remember, we are going to the right of turning point. So x is greater than or equal to 2. So you are getting, I think both answers are positive. So x is equals to 2 minus 1 over root 3. And x is equals to 2 plus 1 over root 3. So if both are positive, except if both are not positive, then you have to choose one. So now let me just go to the mark scheme for this question, because I haven't solved it completely. That's question number 8. So I think 1 will be accepted. I just have a gut feeling. So question number 7, question number 8, A, B, C, D, we are getting 2 answers. And one of the answer is x is equals to 3 only. Now let me check this thing. Hold for a second. I think this is the one. So now this thing is plus 2, and that is 27. Divide by 3 plus minus 3. And this is 1. Okay. I think I've used, no, I have not used up this thing. So now over here, let me just double check something. Let me just double check this working. 3x minus 2 whole square plus 2. Instead of x, I'm writing this thing. So I think I should have simplified it over here. Now, this is the mistake, my bad. I think I did not simplify over here. I should have. That was canceling out. So maybe that is the thing. So now over here, before I proceed, this is 3 bracket 3x minus 2 whole square, this plus 2 and minus 2. It's canceling out, and square plus 2. And let me do one thing. 3 square is 9. 9 into 3 is 27. This is x minus 2 raised to power of 4 plus 2. And then now equal it to 29. So 27, x minus 2 raised to power of 4 plus 2 is 29. 27, x minus 2 raised to power of 4 is 27. X minus 2 raised to power of 4 is 1. Now the fourth root. I think the examiner is too obsessed with the fourth root. So x minus 2 power 4 is a 1. So therefore, x minus 2 is equals to 1 raised to power of fourth root. So it could be minus 1, x minus 2 raised to power of 4. That is taken. That is plus 1. So let me just erase this thing. Hold for a second. Not the whole thing, just this thing. When you take the fourth root, you get a positive as well as a negative. So x comes out to be minus 1 plus 2. X comes out to be 1 plus 2. So x comes out to be 3, x comes out to be 1, reject, except y because of the domain. X is greater than or equal to 2, and this is accepted. So that was a small mistake on my part that I should have cut it out, and I think I skipped this thing out. Question number 9. The diagram shows the curve with the equation y is equals to x cubed minus 3x plus 3, y is equals to this thing, 2 cubic equation. Are very beautifully overlapping one another. There are 3 points of intersection that I see. I see a point of intersection over here. I see a point of intersection, and I see a point of intersection. So that's the most different kind of graph I've ever seen. The diagram shows the curve. Find the x coordinates of the point of intersection. So now we equate the things to one another, and we simplify, and we are getting this thing over here. So now there is no constant term. I took this negative x common, and then I got rid of the negative sign. 0 divided by negative 1 is 0. And then I have this equation, which is quadratic over here. I do the middle term factorization. I get this thing. I get this thing. This x was there on the outside. So that is outside, outside, outside. Now, all these 3 things are multiplying to give you 0. Either one of them is 0. So x is 0, x is 1, x is 3. So therefore, this is 0, this is 1, and this thing over here is 3. Now the area, if it's asking about area, the area is between the 2 curves. Just integrate the 2 curves and plug in the limit 1 and 3. So 1 minus 3, 3. Let me write it over here. 1 minus 3 and 3. I think that is x cubed minus 3x plus 3. It's not 3x, it's 3. And the other one is 2x cubed minus 4x squared plus 3. 2x cubed minus 4x squared plus 3. All good? So plus 3, plus 3. Now, a lot of people ask this question, should we do it together? Should we do it separate? It's their choice. I'll just set up the integral. That is area under this curve between the limit 0 and 1. Actually, no, it's not 0 and 1. It's 1 and 3. Integrate this thing. Area under the other curve between 1 and 3. Integrate this and then subtract the areas. So therefore, this is x power 4 over 4 minus 3x cubed over 3 plus 3x. And the limits are 1 and 3. And over here, this is 2x power 4 over 4 minus 4x cubed over 3 plus 3x between the limits 1 and 3. And then you plug in the upper limit, you plug in the lower limit. So let me write the upper limit, and then the lower limit, and then the area shaded is the difference between the two areas. And then you get the answer. So I'm not going to into the nitty-gritty detail. So now over here, let me show you the other way. The other way is one single working, which is, I think, a better idea because there are many like terms over here. So now which curve is at the top? So there is a +3, there is a +3, and the one which is x cube that looks like at the top. So x cube minus 3x plus 3. So that is over here, area in between. So area between, that is between the limits 1 and 3. This is x cube minus 3x squared plus 3 minus 2x cube minus 4x squared plus 3. And put a big bracket and then a dx. First simplify. So therefore 1, 3, x cube minus 2x cube, negative x cube minus 3x squared plus 4x squared. That is plus x squared, and 3 cancels out. So maybe this is a shorter version. So now let me integrate it. That is minus as it is, x power 4 over 4, and this is x cube over 3 between the limits 1 and 3. Let's plug in the values. So now if I plug in the upper limit, negative 3 to the power 4 over 4 plus 3 to the power 3 over 3 minus negative 1 to the power 4 over 4 plus 1 to the power 3 over 3. And then you simplify. So that is negative 81 over 4. That is 27 over 3. And then this is minus 1/4. This is plus 1/3. You simplify and then you get this answer. The answer is this thing, 8 over 3. So now that thing is done. Now someone can say that what if I mixed up the two equations? I wrote this first, I wrote that second, and maybe the answer is coming out to be negative. So what? I mean, just take the absolute value, that is one thing, or change the order and subtract. So that's not a big deal. Okay, so this thing is done. Question number 10. Now this is about what? It says points A and B have coordinates such and such respectively. Circle with radius 10 passes through the points A and B. Now, the very first thing that comes to a lot of people's mind is that they think that A and B are the endpoints of a diameter. So in this case, A and B are not the end points of diameter. So that property is not used. The property that is used over here is this thing. Let's say there is a chord like this. And let me make a chord over here. And let's say if this is A and this is B. And somewhere here is the center. So let me just make it realistically, something like this. And if I draw a line from the center to this chord, it will be bisect equally, provided it's a perpendicular line. And if I carry on with this line, so let me just extend this line a bit. Okay, so now I think this is the property that is being used. Let's apply it. Show that the center of the circle lies on this line. Now, definitely it's the chord property. That chord property says it all. That is the perpendicular from center passes through midpoint of chord AB. So I have A, I have B, I have the gradient of AB, which is -2. And the gradient of the perpendicular should be +½ Then I have the midpoint 6 minus 1. So let me use this. Let me find equation of perpendicular bisector, which comes out to be ½ x - 4. That means the center of the circle lies on this. And it will also bisect this. Also, if I join these 2 points, that should be the radius. So I have the center that lies on this line. If I join it with A, or for that matter, join it with B, that is the radius. And that is exactly what the second part is. It says find the 2 possible equations of the circle. So let me choose A. Let me choose C as M and N. It lies on the line y is equals to half x minus 4. When x is M, y is half m minus 4. In other words, this is your N, the y coordinate. So we are having this. C is m and half m minus 4. I have taken LCM. That is how I have written it. Is this all clear? So now I'm taking A, I'm taking C. I'm saying the magnitude of this length is the radius. Distance formula, 4 minus m whole square. 3 minus this thing whole square is 10 square. First take LCM. 8 plus 6 is 14 minus m. 2 square, all this thing. A minus b whole square. Let me simplify each one of them. This is A minus b whole square. That is this thing. This is A minus b whole square. That is this thing. This is the denominator square. That is this thing. This 100 is comfortably lying on the side. And now what I have done is that first thing. First, I have taken this 4, multiplied it on this side, multiplied it on this side. So now this is after multiplication by 4. This blue thing remains as it is. And this is now 400 over here. So that is after this thing. That is 400 over here. That is all thing over here after multiplication by this form. Then you simplify, you get this equation. You do middle term factorization, m is 14, m is negative 2. N is half x minus 4. In place of x, write 14. In place of x, write negative 2. I get n is 3, n is negative 5. So therefore, let me just write over here once again. Let me simplify it a bit more. So now one of the point of this thing, the center is 14, 3. The other center, let me call this a C1, this is C2, this is negative 2, negative 5. The radius is common, that is 10. That is why you see 100. And then x minus h whole square, y minus k whole square for both things. And that's how the circle equation is formed. And that's the last question that you're seeing on the screen. That is this one. The equation of a curve is this thing, where k is a constant. Find dy by dx and the second derivative over here. So always make sure everything is in the numerator. And the working is over here. Half comes down. K remains as it is. Power reduces by 1. 4x squared becomes 8x. Then you again integrate this negative half into half. That is negative 1/4. Kx power reduces by 1. Negative 8x becomes negative 8. It is given that k is 2. Find the coordinates of the stationary point. So when k is 2, we have dy by dx. So this half into 2, it disappears. X power negative half, 8x. Equated to 0. Write this thing as 1 over root x. So let me highlight this. So over here, write x power negative half as 1 over root x. Simplify. 1 over 8 raised to power of 2/3. That comes out to be 1/4. And you can use a calculator. You can use indices, your choice. I have done this thing in my head. That is 8 raised to power of 2/3. That is 8 raised to power of 1/3 raised to power of 2, or 8 raised to power of 2 raised to power of 1/3. This is 2 square, which is 4. This is 64 1/3, which comes out to be 4. So the denominator is 4. Therefore, this is 1 over 4. How do you get y? You plug in the original equation. So the original equation with k is equals to 2 is 2 root x minus 4x squared plus 2. That's the original equation. And when you plug in x is 1/4, you find the value of y, which is 11 over 4. So 1/4, 1/4, comma, 11 over 4. That is the coordinate of the stationary point. Plug in the second derivative. It's coming out to be negative. You just need the sign. That's enough. It's a maximum. Now for 6 marks. Now this part was very lengthy, very lengthy. Now it says points A and B on the curve has x coordinates 0.25. This is, let me mark it. So A is 0.25 and then B is 1 respectively. For a different value of k. So now k is not 2. So therefore, let me write this equation over here. That's the equation of the curve. And we also have the first derivative. Let me just plug in the first derivative, which is what? Which is half k root x minus 8x. So dy by dx, it's half k root x minus 8x. Now let's plug in the things. First of all, if I have x is equals to 1/4, y is equals to half of k plus this thing. So we are, find the value of k. That is what we are looking. So therefore, y is this thing. And then dy by dx is this much. So we are plugging in 1/4. We are getting the y coordinate. We are getting the x coordinate. Similarly, we plug in x is equals to 1. We get the y coordinate. We get dy by dx. Now look very closely over here because it's a lot of stuff of algebra. So let me just realign things. Okay. Now let me put a line in the middle. So now what is happening? This is y minus y1. Let me illustrate it. This is y minus y1 is equals to mx minus x1 for both. Your y1 is this thing. Your x1 is this thing. The x1 is this thing. And this is your gradient. Got the idea? If you want this bracket to be removed, that also looks neater. Remove it, looks neater. So now you have two equations like this, two straight line equations with a lot of k and y in it. So let me just grab this thing. I don't know, for some reason it's not being grabbed. Okay, so now substitute x is equals to 0.6. If I substitute x is equals to 0.6, let me write it in black color. Hold for a second. So I'll write it like this. Y, hold for a second. This is y minus half k minus 7/4. This thing is equals to k minus 2. And then x minus 1/4, that is 0.6 minus 0.25. Then the line in the middle. And then this is similarly y minus k plus 2. And this is equals to half k minus 8 multiplying with x minus 1, which is 0.6 minus 1. Now what we can do is that we can comfortably make y the subject, So when we make y the subject, what do we have? We have this thing. Let me make it thinner. So this is k minus 2 and 0.6 minus 0.25, k minus 2, 0.6 minus 0.25, and these two taken to the other side plus half k plus 1.75. Over here, this is half k minus 8, 0.6 minus 1. Half k minus 8, 0.6 minus 1. Take these two terms on the other side plus k minus 2. Equate, solve, you get the value of k, that comes out to be 3. So that's how this particular paper is done and dusted. And this was October-November 2024, variant 1-3. That's all from my side on Mathematics with Shahab Yaqub. Take care, everyone.